My name is Chenxi, called Bertolino. And we made a wireless transmission message machine using our Nexus 2 board. So basically we have two Nexus 2 boards hooked up to the laptop, and then both machines are set to a default mode of transmission stage. And then once you press the button 0 for the Nexus board, it will create a message, and then you can input messages by pressing the 0 button, going to different characters. And then once you have your message, you can press the button 3 and 0 for that message to be sent to the next Nexus board. And then the first Nexus board will go back to the initial default state, which is the receiving state, while the second Nexus board will go into the read state. And then after it reads the message, it becomes interrupted and then goes back to the receiving state once again.
Okay, so the main thing we added was the transceiver, and kind of how software flows is that the data starts on the LCD and it comes from the switches, and then that goes into the array on the microcontroller and outputs it to the transceiver, then it kind of reverses, goes into the other transceiver, comes in and goes out to the LCD. So the transceiver receives and transmits data, it uses SPIs and interrupts to communicate with a microprocessor. The LCD displays messages, they're created with the switches, and LEDs just kind of give like state information, like whether you're in the transceive state, or transmit state, or receive state. And, I guess I should talk about this stuff here. Okay, and then to communicate with the processor and the transceiver, like the main two things you do is either read or write registers, or read or write the buffers, the 128 byte buffers. You would read and write the registers. There's the state registers, which control which state you'd be in, and then you'd read the status of the state to figure out if you're in the receive state, transmit state, the startup state. And then you would get one general interrupt, and then you'd have to check the interrupt by getting the interrupt status, and there's 8 different interrupts. So you'd have to figure out which one and what just happened. And then you would read and write to the frame buffers the data from the LCDs, and once you wrote to the frame buffer, you would change the state to the transmit state and would send whatever was in that buffer out, and then you'd receive it into the receive buffer, and you'd get an interrupt indicating that you just received all the data, and then you change the state to read that in. The upper level software would just control that. It would poll for the different interrupt status and buttons, and like change the states to the proper state depending on the user input, and get the message and transmit the message. And our demo is just transmitting messages back.
Let's get to it. I am just going to create a message.
And it's kind of like a very custom interface, I guess.
Yeah.
It's kind of, and the LEDs indicate that he's in the create message function.
Okay, and then once I'm done sending it over,
and I receive it. And that was, so interrupt caused that to go into the receive state, and then so I can send any message, and I guess just I don't know, just kind of show what it. So you can send any character, like any length, any amount of words. You can go back and edit your message, and
go into
I don't know, I'm kind of being lazy, but and you can like the switches. You can go to any ASCII letter, so you can go capital, or small, or whatever. So I don't know what that is. Okay, so some big A, and then send it.
once you
And makes this his, and reads all that chunk. So yeah, that's about it.
And then press the 0 button again. I go to the sending mode.